One line of code just sorted an entire list of student scores, highest to lowest. That's the power of Python lists. Let's learn everything about them. Lists are Python's way of storing multiple values in one place. Think of a list like a shelf in your kitchen. Each slot holds one item and you can add, remove, or rearrange items anytime you want. You will use lists in literally every Python project, from building apps to processing data to training AI models. Today we will cover three things: how to create and access lists, how to modify them with built-in methods, and a real-world practical example you can use right now. A list stores multiple items in one variable. See here, fruits is equal to apple, banana, mango, and orange. These are multiple items that are stored in a list variable called fruits. These multiple items can be accessed using index. The indexing starts at 0, not at 1. Just like strings, lists are 0 indexed. Index 0 is the first item. See here, apple. Index 1 is the second, banana, second item. And negative indexes let you count from the end. -1 is always the last item. Fruits, -1 index. There is orange, which is last item. What happens if we go out of range? See here. Here I have executed a command printf, print fruits 10. Fruits 10. I mean, here we are supposed to get the item at 10th index. See that? Index error. Python is telling us index 10 does not exist. Always remember, your max index is the length of the list minus 1. Now let's fix this. How? Now, first of all, we have to find the length of the fruits using length of fruits. I'm executing it. See, what is the length here? 4. So valid indices are 0, 1, 2 and 3. Now I'm executing this line of code. See what will be the output? Orange. The item at the index 3 is orange. Obviously, this is the last index. Why? Because the maximum index is the length of the list minus 1. Here length of the list is 4 and -1 is 3. This is the last item, which is orange, here, last item. Now moving to list operations. These are the methods you will use in 90% of real projects. Append adds to the end. See here, fruits.append, grape. It added at the end. Append adds to the end. Insert puts it exactly where you want. See here, insert. Fruits.insert 1 kiwi. Whereas append adds to the end, but insert puts it exactly where you want. We are inserting kiwi at index 1. So this is the output. Remove deletes by name. See, fruits.remove banana. It deletes by name and pop removes by position. If no position is mentioned, then it automatically deletes the last item. Coming to slicing. Slicing works exactly like it does with strings. Now, see here, I'm executing this line of code. Execute. See, remove. Remove throws an error if item does not exist. I have mentioned here for removing banana. Okay, as banana is not there in the list, it throws an error. Item value error. Item does not exist. X is not in the banana is not in the list. Okay, always check if the item exists first using the in operator. This is the use of in operator. What is the use of in operator? In operator is used to check whether the item exists in the given list or not. Okay, now always check if the item exists first using the in operator before calling remove. Otherwise, Python throws a value error. Then how to fix it? See, this is the code. If banana in fruits, then we have to execute this line of code, that is fruits.remove banana. Else, print banana is not found. I am executing this line of code and check what will be the output. Banana is not found. As banana is not found, see in the above example, we executed this code fruits.remove banana. It throwed value error. Now, as we executed this code, if banana in fruits.remove banana, else print banana not found. As banana is not there, it printed banana is not found. Now, a real world example, which is student score tracker. This is something you would actually build in a real app. A score tracker with just 5 lines, we can add a score, find the highest, lowest, calculate the average and loop through every result. Okay, loop through every result. This is a real world example. Let's wrap up. Lists are used to store multiple values in order, and you access them using zero-based indexes. Built-in methods like append, remove, pop, and insert let you modify lists on the fly. And the length, max, min, and loops you can build real tools straight away. Now, viewers challenge. Create a list of 5 favorite movies and add one more with append. Then print it reversed using slicing. Drop your output in the comments. I read every single one. Next up, Python dictionaries. If lists are a shelf, dictionaries are a labeled filing cabinet. And they unlock a whole new level of Python. Subscribe so you don't miss it.